Hi and welcome to another episode. What I've got here is a PCB that is designed to convert your Atari standard type joysticks to USB. Now I do want to point out this has been backed by PCBWay. I'm not the designer of the PCB, but with PCBWay, as I say, they have graciously sent me these PCBs and I've had to buy the parts myself to build it up. I'll talk more about PCBWay in a bit. What I want to do right now is talk about the PCB. It was designed by a person calling themselves TEBL, I believe you pronounce it, TEBL. They're from Norway and they've put it up on open source up on PCBWay's website. So let's get on with building this. It's to convert, as I say, your Atari style joysticks to USB. They've called it the Commodore 64 Joystick Adapter, but as you can see, there's a gamepad or you have a joystick. So this doesn't actually do anything apart from help protect the circuit board and give you an idea of which way you have built it up. So let's drop out all the parts that are needed. There's a fair bit to get through. There's some micro switch buttons. Don't worry, I'll put a link down below for everything that you need, but also of course on where to get the PCB and the GitHub page on how to flash everything across and the BOM for the parts anyway, but I'll put some links. There's some what's colloquially called DB9 ports, male ones, not female ones. Some LEDs, some 330 ohm resistors, some I believe these were 220k ohm resistors, so we've got them hanging around. We've also got, what are these called now? We've got 5 of them because I've got 5 of the boards. Is an Arduino, so let's get into this. So there's a fair bit of soldering to be done, as you can see. So I need the Arduino, I need to solder on the pins onto there and on the other side and then onto the board and so on and so forth. Now with the PCB, as I say, there's joystick or there's gamepad for the Master System or the Mega Drive or Genesis as you may call it, 3-button or 6-button. The firmware also allows it to be done for the Commodore, the C64 Mini, because it needs sort of a special one for that. It may need some updates for some other things. I've seen that some people complaining that the second 5-button on a Commodore joystick doesn't work on a Mister. So who knows, hopefully things will get updated for that, but for me, just to be able to use it on my PC will be nice. But it was just a bit of a project to do to get my hand back into soldering again. So let's start off with soldering up the Arduino, because that's going to be a boring bit, I suppose. I'm not exactly going to show you me soldering every single pin because that would make a very boring video, but you're going to get to see me at least try to do different bits and see how well we do, and it will get more detailed a bit when I'm actually flashing the firmware. So let's solder on the parts needed to get a joystick working. Oh, completely forgot this thing, and it's massive in comparison to the bits. This is just the screws and the posts that are needed to separate the PCB, and then this little bit on top as a notifier of which one you've done. Anyway, back to the soldering. So, got the PCB, this is the underside of it, and what I'm going to do is put the short end of the pins from the top side of the PCB so they stick out at the bottom. I don't know if this is the correct way of doing it, it's just that there's going to be some plastic nuts and plastic posts, and the nuts are going to be on the bottom side, which are going to act a little bit like feet. And so we don't want pins sticking down further than the feet or the nuts. So I'm making sure it's a short end there, because if the longer side, basically it'll be fine as it sticks through the top, because there's not going to be anything in the way to mess things up. So that's the way I'm thinking it through. Let's get on with doing bit by bit. So we put some flux on, like you should always do. Don't need loads, we just need some. And we'll get on with doing this set of legs first, and then we'll do the other side by making sure that this is getting everything lined up properly. So at the moment I'm just going to do one pin and then put the other set in, do another pin to hold it in place, put this on top so that the angles are correct for the pins, and then solder the rest of them, and then solder the top side of these ones. So some solder and a soldering iron. Shall we zoom in a little bit so you can maybe see? Or the super fast zooming. Let's move it up a little bit. So as I say, I'm just going to do one for now. There we go. And then we'll put, see, it's a bit of a funny angle. So we'll put this one in, and then we'll put another bit of a funny angle. We should be able to see, not quite right, is it? So we need to make sure they're fine. I can maybe use this as a way to straighten things up. There we go. Nicely lined up. Was that all off camera? Oh, it probably was all off camera, wasn't it? So now that I've got that one pin done, I can rest the Arduino on, and I can make sure that this is all flat here, and that fits a lot nicer, making it go down. So I just need something to balance this up, so we'll use some of these to make it all sit nice. So let's move it along so you can see. I know you're going to be a bit off to the side, but my camera's stationary straight down the middle there, for me at least. So maybe I can move it across a little bit, but I haven't really got a lot of give. So we'll get on with soldering all these different posts now. Pins! Used a bit of tape to help stop things sliding all over the place, and try to finish off the rest of the soldering. So there we go, that's every single pin soldered. I believe everything's all okay. We'll find out the hard way when it comes to flashing it, making sure it works with everything else. I'll clean off the board from the flux when everything's soldered, because that's the only reason of doing that. Now, the one thing I do want to point out is these 4 bits here for when it comes to putting the ports on. You have to tell it which mode you want it to be in, not only here but also in the firmware. So I want this one to be a joystick one, so as you can see there's 3 dots. So the middle one and the outer edge one is for Atari, same for that, and same up here. So I'm going to do that for all 4 bits by adding some flux first, of course. So I believe it'll be easier now, before installing the joystick ports, is to get the little components on. So we need some 220k resistors. We need 4 of those. Now please note, if you're listening to this at the moment, is that if you come to do the Mega Drive version, there's a different thing you've got to do. You have to, on the back, solder up 3 and 2 pins along of those. Basically the one that isn't square, you'll notice from before in the video there's a square one, that's 1, 2, 3, you have to count it from right to left. So the 2 circle ones you need to solder up on all of them if you're going to use gamepads on all of them. And you only install the R5 resistor, R1 to R4 you do not bother. But for the joystick you need everything that you've purchased. So we need 4 of them, and we need 1 of these, which I'll install last so I don't get confused which one's which. So we just need to mess around and push these through. I know there's gadgets you can get out there that bend resistors just right, but I can do this one myself. And anyway, I'll do bit by bit, as always, bit of flux on the back, and get on with doing the soldering. So time to snip off the legs. One thing I like to do with my clippers, which I've learnt over the years, is to actually magnetize them, because then it helps stop these going ba-ding all over the place. Put them there for now. So that's nicely soldered. Maybe I could have snipped a little bit closer on some of them, but that should do. Yep, that's fine. Alright, let's get the LED installed, and then maybe the buttons, then the ports. So, which colour of LED shall we pick? I've got green or red. For those that follow the channel, you already know which one it's going to be. So with the LED, it goes in here, because that's the symbol for an LED. And the way that I like to try to remember, not always, but I like to try to remember on which leg is positive and which one is positive, and the same with the symbol. And I basically try to remember that the negative is the bit that's been taken away, you know, minus. So the flat side is the bit where the circles had a bit taken away, and the short leg is the bit that's been a bit taken away. So they line up. I fit that in there. I get some flux on, and then we'll solder that into place. I believe that's a good bit of soldering there. So time to get what's left. It really, the buttons, that's the one that I want to do next. I need to remember which one is the, oh, that's the reset and the mode button, but I need to remember which one is which. Well, here's an interesting fact. The pins on the Arduino do need snipping, so it's up to you which way you put them in from the stuff. It's sort of cleaner that direction, but this was a bit fiddly to try to snip off, especially with the LED in place. Basically, I've figured out that the mode 1 for this switch is the longer button. Maybe could do with being a little bit longer actually, but we'll find out. So we rest that there, and it's just there. And that's the thing, is that the pins of the Arduino were just in the way. But let's get these two buttons soldered on now. Same as last time, some flux, some solder. That's the buttons soldered in. So time for the ports. So they just fit in. There is some sort of anchor points where it's going to need quite a bit of solder. So we'll do that first to make sure that they're in. Let's make sure they point the correct way around. There we go. They just about click into place, but at the same time we need to make sure that they're nice and flat. So I'm going to put a fair bit of solder on one side, push down while I'm got some on, and then add more, and then do the same on the other side to make sure it's all flat before I do the actual pins. So I think that's everything done now, all soldered up. Got the anchor point soldered, we've got the pins soldered. So what we need to do now is figure out all the bits and pieces to make this fit on here. So we need all the nuts and bolts, as it were, for there, and then we need to flash it. So I've been trying to build up the top part with the nuts and bolts and everything else. Now the BOM asks for M3 8mm with a hex standoff, which is what this is, and I'm actually going to be using M3 10+6 because the M3 8mm is just too short. It actually makes this part bow, and the reason why it makes it bow is because the bits here for the joystick ports don't sit in between the two joystick ports, they sit on top. So either they need to be brought in a bit so that they slide down far enough, or use the M3 10mm, but then buy yourself a longer button, because this is now below where the hole is. And I'm not going to snip these bits off because I actually want it to still say port 1 and port 2. I know I could print out my own stickers and things like that, but as you can see, it doesn't actually slide down, and you can't tell me I haven't soldered them flat to the board, because I have. So that's not the problem. It's a slight design fault, only a slight one. I can't design such things, so you know, I'm keeping my mouth shut on like stuff. It's within tolerances, I suppose, of what you can get your hands on, and really I think it should either be this definitely slides down and rests against the LED and the button sticks through, or try to pick up some other tolerances so that, you know, one size fits all sort of thing. And with that, I think that these little leggy bits should be shorter so that the whole thing can slide down. But let me mess around and build it up and not get these standoffs in the wrong place. And as you can see, these are the ones I've been picking from, M3 times 8 plus 6 and M3 times 10 plus 6. Because it was a bit awkward actually getting a little pack that had everything in place anyway, because otherwise it gets stupidly expensive. But as I say, I'll build this up now and let's have a look what it looks like. First things first, you may all see on here that these nuts are flat and that one's beveled, and that one's flat, but I can flip it over and it's beveled. You can tell by the shine. Now the bevel bit should be on the inside of what you're screwing together, mainly because you actually want less surface area in the join, because it will make it easier at a later date if you're trying to undo them. It's probably not such a problem with these plastic things, but you know, real world scenarios of where you're using metal bolts and nuts and everything, that comes in handy, especially if you want to squeeze some oil or WD-40 type substance down there. But as I say, I'll mess around now and build all of this up. As we can see, there's a bit of a bow even with these size bolts or standoffs. So yeah, these bits need to be redesigned so that they go down, or use slightly taller standoffs and use a longer button, which quite frankly is the quicker fix. So there we go. So these were M3 times 10 plus 6. You might want a M3 times 12 if that's what they make, plus 6, and then get a what was that? That was a 9mm button you might want, well, a 13, 14, so it sticks through the top. And the LED you could just leave on longer legs and stick it closer to the top. And quite frankly, I think I would use a skinnier LED as well, maybe. Who knows? Main thing is though, let's get on with flashing it and see if it works. My thanks goes to PCBWay for sponsoring this episode. Currently they have their 8th anniversary promotion. They're offering free coupons, sales and a lucky draw. One of the things they're excited about right now is their new OEM service, which means they'll put your creation together for you using your designs with the great services they've always provided. These ranging from PCB assembly, 3D printing, CNC machining and many more. Your first order could start as little as $5. Okay, back to what we were doing. What we need to do is install the firmware onto the gadget that we've just built. So let's go across to here, which is on PCBWay's website under the share area that they have. And there you need to go and find the C64 joystick adapter, but don't worry, I'm going to put a direct link to it in the description down below. And then of course what you're going to do is read every single word of the steps that the guide tells you to do. So here's a description of everything. But what we need to click is GitHub. That'll take us to another page, and the first thing you should do is click code and then download the zip and unpack that to some place you're happy for it to be. Then you need to scroll all the way down to, where is it now, installing the firmware, and you need to grab the Arduino joystick library. So right click over there and you get code there as well and download that one. And if you're going to build the gamepad, the Sega version of it, you also need to go across and grab that bit of code as well, that library. Now these two zip files, do not unpack them. You don't need to unpack the last two files. Then what you need to do is go get yourself the Arduino installer, which is easy to find. I'll also put a link to that as well. Install that, make everything all up to date and everything like that. I'm just going to start that up. I've got a flash screen on my other screen, so I'm going to put it across. Currently the latest version is that one, it seems. What you need to do is go to Tools and then make sure you've plugged in your little gadget that you've built. You go down to Board. Now the one that I've particularly got is a Leonardo one. So as you can see, it's there. So that should be fine. Make sure the port is done. This little bit I can't tell you definitely because it depends on the Arduino Micro Pro that you've got. They're a little bit different depending on who you're buying them from. I got, I think it was 5 for £20 that I bought them for. I think that's how much they were. So double make sure the one that you've got. Sorry, I can't inform it that much more than that, but what if you can do is click at least the Leonardo or the Mini, and then you can go to get board information, and then it will tell you definitely which one it is, and then make sure you set it to that particular one. And then what you need to do after you've done all that, so we'll pretend we've done all that and then gone back up to Tools again, then you need to manage libraries. And make sure everything is up to date here. If it's updatable, make sure you update it. Everything I've got is already fine. And then you go into Tools again. So you go into Sketch again, and you go into Include Library, Add Zip Library. Now those last two files you downloaded, add them one by one. Then you go to File, Open, and you go through your file structure until you find Joy Converter through the first file that you downloaded, and then you need to load joyconverter.ino. click open, and as you notice I've already got all of that. And then if everything's set up properly, you should be able to just press the arrow that points to the right, which means upload, and it'll compile, it'll mess around a little bit, and then it'll say done uploading. So you should be able to close everything down, but don't right now, just leave this the way it is. Close, minimize your browser, because we might need this in a moment. Then on the particular version of Windows that you've got, click the magnifying glass so you can search the apps that you've got installed on Windows. I'm sorry, I don't know how else to do this on a Mac, but on Windows you can type in Joy, and then you'll see a bit that says set up USB game controllers. I'll just take a screen grab of this for now so you can see what we've got going on. I'll add that into the video, but what we need is for that to actually start up, and then you should be left with the name of the Arduino that you've got. So if you've got a micro, it'll say micro, but in our case it's Leonardo, sorry. Then you click properties. Now unplug your little gadget that you've built, plug in a joystick. I've got a zip stick, you know, one of those black ones with the yellow buttons, and then we plug that back into the computer, and then we should be left with click properties, and then we should have this if you're doing the joystick side of things. Now this being a zip stick, it doesn't actually have the second joystick, sorry, the second fire button from like the original Commodore 64 joystick does do. You know, there's a fire button up on top and there's one on the base, but we now have up, down, left, right. You can hear the micro switches of the zip stick clicking, and the fire button works. So there we go, works first time. Amazing. Well, great stuff. It worked first time. Joystick plugs in, everything's great. So I hope that was of some interest to some people out there. Thanks again to PCBWay for sponsoring. Thank you for TEBL for testing it. I believe it's pronounced Tusen Tak when you're saying it in Norwegian. Thank you very much. I think that's how you say it. But everybody else, check down below for all the links that you need. Check down below for Discord and Patreon links. Click that subscribe button, hit that like button. Don't forget that notification bell. But as always, happy gaming.